just for this one, I'm going to show you why that's the case. For the other ones, I'm just going to have you take my word for it. So, if we think of sine, sine is opposite over hypotenuse. Right? Cosine is adjacent over hypotenuse. And when we're dividing fractions, it's easy as pie. We flip the second and multiply. So that would be opposite over hypotenuse times hypotenuse over adjacent. And what's going to happen with both of those hypotenuses? I'm not sure how to say that there. What's going to happen with the hypotenuse on top and the hypotenuse on bottom? They cancel, right? And then, so if you multiply across, that leaves you with opposite over adjacent, which is tangent. So that's the proof. That's the mathematical reason why tangent theta equals sine theta over cosine theta. So we need to know that tangent equals sine divided by cosine. Secant, secant is abbreviated SEC, and secant is 1 over cosine of theta. And I could do the same thing over here to show you why that's the case, but it's really not. You can take my word for it. Cosecant is abbreviated COS. No, it's not. CSC. Sorry. Lose my mind. CSC. And cosecant is 1 over sine of theta. And cotangent of theta is cosine theta over sine theta. So to help me remember these, whenever I look at these, what I think of to remember which one's which is that there has to be a co in every pair. And obviously, tangent and cotangent go together, right? And these are called our reciprocal identities. So basically, we just flip them. So if you know tangent and sine over cosine, then you're just going to flip it to get cosine over sine for tangent. So there has to be a co with every pair. So secant of theta, I know it sounds like it should go with cosecant, but it doesn't. But secant doesn't go with cosecant, even though it sounds like it should. Secant has to go with something that has a co with it. So if it's not cosecant, then that just leaves us sine and cosine. So it's got to be the 1 over cosine of theta. And then, so if secant goes with 1 over if secant is 1 over cosine, then cosecant has a co. So it's got to go with the one that doesn't have a co. So it's got to go with 1 over sine theta. So cosecant can't go with cosine because that would be 2 co's together. We can't have that. And I don't know why tangent and cotangent go together, which is so nice. And then sine and cosine don't. And secant and cosecant don't. I don't know why they named them that way. I was not involved in the naming of these trig identities. So these we need to know, and we're going to need to use them for what we're doing here. So exact values of these problems right here. I am going to, let me find a unit circle real quick. You guys can look at yours that you've got there. I just want one on the screen that I can point at. Should have done this ahead of time. Oh, there it is now. I just need to be patient because my computer's very slow. Okay. So, if we are given sine or cosine and we're given something that's on the unit circle, finding it is very simple, as long as you know your unit circle. So if we're asked for sine of pi over 2 is right here, and sine is the y coordinate, so it's 1. So our answer for that one right there would just be 1. So we just go to that angle on the unit circle, and if it's sine, we'll give the y coordinate. If it's cosine, we'll give the x coordinate. And so the value of sine of pi over 2 is 1. If you type that in on your calculator, you've got sine of pi over 2. Oh, it might not work if you're not in radian mode. On your calculator, if you hit mode, it's either in radian or degree. So if you put it in radian mode, because pi over 2 is a radian measure, then if you do sine of pi over 2, it gives you 1. Okay, so you can double check yourself on these. Although typically you're not going to have a calculator if I'm giving you a quiz or test on this, but to check your work as you go, that will work fine. If we are looking at cosine of 5 pi over 6, we're just going to look. 5 pi over 6 is right here. Cosine is the x coordinate. So we get negative square root of 3 over 2. So if you have sine or cosine and it's a value on the unit circle, you're just finding that angle and then reading off either the x or y, depending on what you need. Now, the next one's a little bit weird, because it has a negative angle. So the unit circle goes in a counterclockwise direction. So this direction here is your positive direction, and this direction would be your negative direction. So you've got a couple ways that you can do number 3. I think the easiest way is to do this. Pi over 3 is right here. That's this far on the unit circle. So if I want negative pi over 3, I'm just going to go that far, that same distance, but in the negative direction, which is 5 pi over 3. Okay, and then so 5 pi over 3 is the same as negative pi over 3. And so since that's the same, we want sine. Sine is our y coordinate, so we're going to get negative square root of 3 over 2 for that one also. So basically what this is, it's easier to think of with degrees than it is radians. But if I were to stand here and you told me to turn 90 degrees clockwise, so let me stand this way. So 90 degrees clockwise, the clock goes this way, so 90 degrees clockwise, right? I'd be taking this direction. So what could you tell me to do besides turning 90 degrees clockwise, or I'm going to end up in the same position? I could go 270 counterclockwise, right? So it'd be 90, it'd be 180, this would be 270. So that is really just the same in both directions. And then if you wanted to, oh gosh, to go like, you could tell me to go like 2,250. That ended up in the same position. But I'd have to spin around a lot of times first. I'd be dizzy by the time I got to that position, right? So the unit circle works that same way. So so for this, like when I have that negative degree, negative pi over 3 is the same as 5 pi over 3. It gets you to that same position on the unit circle. The other way that you can do that, and I don't usually use this for simple ones like negative pi over 3, but I do sometimes use it if it's really like crazy big ones and I'm not sure where it ends up. What is a full rotation on the unit circle in radians? 2 pi. So if I take negative pi over 3, if I do a full rotation, I'll end up back at the same spot, right? So if I do negative pi over 3 plus 2 pi, that's negative pi over 3 plus 6 pi over 3 if we get common denominators. That gives me 5 pi over 3, which is the spot that I ended up at here. So you can do that if it's one that's kind of harder to visualize there. Okay, questions on 3? It depends on whether or not it's asking for sine or cosine. So if it is sine, you're going to take the y value for that. So for this one we had sine, so we used the y value there. If it was cosine, we would have said 1/2 as the answer. Okay, next one is 3 pi. 3 pi is not on the unit circle. So you could do it algebraically, and you could think, well, 3 pi is too big, so I could subtract a full rotation, which is 2 pi, and that gives me 1 pi. So 1 pi is right here. Sine is the y coordinate, so I get 0. Or the way that I usually do it is this. The way I think of it is pi is half the circle. So if I've got 3 pi, I just go, there's 1 pi, 2 pi, 3 pi, and just kind of count around for that. Okay. This one, negative 11 pi over 2. That one's definitely not on our unit circle, right? So negative 11 pi over 2. Pi over 2 is a quarter of the circle. So this is the way I do the problem. I normally will do this. I will start here, and I'll go, we're going negative direction since it's negative pi over 2, so we're going clockwise. So there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. So I just count. Each quarter of a circle is a pi over 2, and I just count around. So pi over 2 is the same as negative 11 pi over 2. And we want cosine, which is our x coordinate there, so this one is going to be 0. Okay, nothing tricky about sine of 3 pi over 4. Richard, what would sine of 3 pi over 4 be? Make it a little bigger so you can see it. 3 pi over 4 is in the first, second, third, or fourth quadrant. Okay, first quadrant, top corner over here. Second's over here. Third is down here. Fourth is over here. So 3 pi over 4 is at first, second, third, or fourth quadrant. First, second, third, or fourth. Okay, it's right here. Can you see this? That 3 pi over 4 is here. 3 pi over 4 is right here. And we're asked for sine, which is our y coordinate. Okay, so at 3 pi over 4, y coordinate is square root of 2 over 2. So we'll have square root of 2 over 2. And this is the same thing you do when you use your calculator. It's just you don't have to use a calculator for it. Like if you type in sine of 3 pi over 4, it's going to give you this, which looks like, this is not in, hold on, it's not in radian mode. It's going to give you this, which it looks like nonsense, but square root of 2 over 2 is the same decimal, so it's square root of 2 over 2. There. Okay, let's do some more. This one we definitely need to talk about. So tangent of pi over 4. Pi over 4 is fairly easy to find. It is on the unit circle. It's right here in that first quadrant. So pi over 4 is on the unit circle, but tangent is nowhere on the unit circle. So this is where you have to use those identities that I showed you on the last slide. Rather than doing tangent of pi over 4, because we can't, it's not on the unit circle, we have to say that sine of pi over 4 divided by cosine of pi over 4. So sine is my y coordinate, so that is square root of 2 over 2. And cosine is my x coordinate, which is also square root of 2 over 2. So what is the square root of 2 over 2 divided by the square root of 2 over 2? It is 1. So when you see one that is not sine or cosine, it's going to take a little bit of extra work. All right, secant of pi over 2. Again, pi over 2 is fairly easy to find. But secant's not on the unit circle. So secant equals 1 over cosine of pi over 2, which in this case is going to be 1 over, cosine is your x coordinate, so 1 over 0. What is 1 divided by 0? It is not 0. It is undefined. You cannot divide by 0. 0 divided by 1 is 0, but 1 divided by 0 is undefined. This is where my freshmen had the idea that we create calculators that explode if you try to divide by 0. I think it'd be a good plan. I think if we created these that only had like a light explosion where nobody's going to get hurt, and you had to pay for the calculator if you exploded it by dividing by 0, because otherwise kids would just be like blowing up their calculators all the time for fun. But I think it would work if they had to pay for it. Nobody would ever divide by 0. Okay. Cotangent pi over 6. So you would look at pi over 6 here. Cotangent is going to be cosine over sine. So cosine over sine is going to be the x coordinate, which is cosine, divided by the y coordinate, which is sine. So we get square root of 3 over 2 divided by 1/2. And dividing fractions is the easiest pi. Flip the second and multiply. Those 2's right there will cancel, and we'll just have the square root of 3. Let's see. Let me see if there's any others that are important for us to look at. Let's look at 14 real quick. For 14, you're looking at negative 5 pi over 6. So 5 pi over 6 is right here. So negative 5 pi over 6 is going to be that same distance in the opposite direction. Or if we want, we could think negative 5 pi over 6 plus 2 pi. It's going to give us 7 pi over 6. And so we're looking for secant. Secant is 1 over cosine. And so cosine at 7 pi over 6 or negative 5 pi over 6 is our x coordinate, so it's negative square root of 3 over 2. Okay, and dividing fractions is easy as pie. Flip the second and multiply, so 1 times negative 2 over root 3. So we get negative 2 over root 3. But we can't leave it like that because it's got a square root in the bottom, so we're going to rationalize. So we will get negative 2 square root of 3 over 3. Okay, questions? All right, I'm going to get